two limits of integrals with t up there, right? So we're going to have first... What?
You have to do it in two limits. I usually do it in one limit and then go from...
Let's do it. Let's just... I see what you're saying. Let's just do it in two. I understand. It's basically you're combining the notation, which is fine. Just be careful. You're usually careful enough that I think that'll be fine. Let's just break it up into two. No, you can. It's just what's going to happen is you'll get a proper answer, but at some point there'll probably be something that technically isn't correct in terms of the overall expression. It's like when people don't change the limits of integration, but then go back all the way to x. So they get the right answer, but along the way they wrote something in terms of u with not u limits of integration. So anyway. So this is the limit as t goes to negative infinity of t to 0 of x over 1 plus x squared dx plus, oh, we need another limit, right? The limit as what? T goes to infinity, and I can't draw with this thing today. T goes to infinity of the integral from 0 to t of x over 1 plus x squared dx. Nice. So yeah, you have to integrate this, and what method can you use to integrate this? U sub u equals 1 plus x squared, so du is equal to 2x dx, dx is equal to du over 2x. So now you have, and again, we're going to do this very carefully. I'm going to delete the limits of integration right now. We have x over u times du over 2x, what nicely cancels. The x cancels, which is nice. So you end up with a limit as t goes to negative infinity of 1/2 over u to the negative 1 du. But what does u equal? Yeah, so we're going to make this all the way back over this. We're not going to... oh, you want to integrate? Excuse me. Yeah, you're absolutely right. Let's integrate first. You're right, of course. Yep. Yeah, of what? ln of, let's just say absolute value of u, like this. And then we have the limit here still, right? You could, but the whole point of keeping it like this is so that the integration is easier. Now we substitute back in afterwards. It's a little bit easier. In this specific case, it's not much easier, but let's just keep it like this. So we have 1/2 of ln of the absolute value of 1 plus x squared. It's still always going to be positive, so we can nuke the absolute values if we wanted to. And then over here, we're similarly... oh, and then what are we evaluating this from and to? Remember? 0 to... so t to what? T to 0, right. So now we need to actually do this out. So you have the limit as t goes to negative infinity of 1/2 times the ln of 1, ln of 1 minus the ln of 1 plus t squared. What's ln of 1? This goes to 0, so you end up with negative 1/2. So the limit as t goes to negative infinity of negative 1/2 of ln. Yeah, I put the negative in front there. 1 plus t squared. What's that going to go to? Well, t squared. Oh, absolute value. Well, it's squared, so it's actually okay here. But no, you're right. You can. It's fine. Absolute value. But you square it. It's big. You're squaring a huge number. ln of a huge number is going to keep on getting bigger. So what does this go to? And so at this point, what can you say? Divergent. Yesterday, we did the other one, and we're like, oh, it goes to negative infinity. So the infinities cancel each other out. We're going to avoid doing that. Just do one.